Hi students. So today we'll discuss one of the very important and very basic concept that must be known to all the science students. That is calculation of pH for acids as well as bases. Okay. Let us discuss in this session very clearly. Okay. So before starting the session, you just click on the like button so that it will recommend to the other students also. Okay, right. So let us start this session without any delay. Yeah. So if you remember that we discussed about acid-base theories like Arrhenius acid-base theory, Bronsted acid-base theory, the next Lewis acid-base theory, these things were discussed in the last sessions, right now. So now we'll be giving you a glimpse of it, then we'll discuss about the pH. Okay, so now look at this. Arrhenius acid-base theory says if you place the particular substance in the aqueous medium, that increases the concentration of H plus ion. Then you can call that substance as acid. Okay, once again look at here. If this is a container, okay, having water. So now in the water, if I place a substance, okay, if I place a substance, let us say HA is a substance, I am placing in this water. Now what happens is, this substance releases H plus ions. It means concentration of H plus ion in this container, in the water, increases. Since it is increasing the H plus ion concentration, you can see this substance as acid. Similarly, I am placing one more compound like this. BOH is a compound. Now I am placing this substance in the water. Now what happens is, that substance increases hydroxide ion concentration, OH minus ion concentration. Then you can say this as base. If it is increasing H plus ion, you can say acid. Increasing OH minus ion concentration, say base. Like this we can say. For example, HCl is an acid, okay, because it increases H plus ion concentration in the water. Similarly, if I write KOH, so KOH increases this OH minus ion concentration, you can say this as base. Okay, like this we can identify acids and bases. Okay, yeah. So now let us enter into the discussion of pH. So when it comes to pH, how can we calculate? So pH can be calculated using the formula like minus log concentration of H plus ion. So what does it mean? Let us take HCl acid. Okay, now when you place this HCl in the water, what happens? It increases H plus ions and also releases chloride ions. Now do not bother about this chloride ion, you just look at this H plus ion concentration only. For example, I am saying this acid has concentration of 10 power minus 2. What is the concentration of acid? I am saying 10 power minus 2 molar. Since H plus ion is also coming completely from this HCl, its concentration also become 10 power minus 2 molar. Okay, right. Now what happens to the pH formula? pH is equals to minus log concentration of H plus. What is the H plus ion concentration given? 10 power minus 2. Okay, right. Then pH will become minus 2. See, if there is something like this, log A power B is there, you can write this as B log A. Okay, so here also log 10 power minus 2 is there. So minus 2 can be written over here. So minus 2 into minus 1, that becomes plus 2, right? So log 10 is 1. So log 10 is 1. So what is the pH of this solution? So it will be 2. Okay, so it will be 2. You just represent it as 2. Okay, like that, can you calculate a question here I am giving? Yeah, concentration of H plus ion here. An acid HCl is given having concentration of 10 power minus 4 molar. So find the pH of this particular acid. Now same steps, use same steps. Instead of using 10 power minus 2, you put 10 power minus 4 and calculate this and tell me your answer in the comment box now itself. I will give you 1 minute, you try it. Yes, you have to do this now. Okay, now tell me, how can you say this? So pH, I told you it has minus log concentration of H plus, that is 10 power minus 4. Okay, so you can write minus and 10 power minus 4 here, it becomes plus 4. This is your pH. Okay, like this you can able to calculate pH of the given acids and bases. Okay, so till now the examples are for acids only. When I say base, let us take a base. Let us take a base. Let us take NaOH as a base. Now how much OH minus ion concentration here? Yeah, they will provide that. Like 10 power minus 2 molar NaOH solution is given. See, NaOH is a basic substance. If you place this in the aqueous medium, it releases OH minus ions. Since it is giving hydroxide ions, you can say the substance as basic. So when hydroxide ion concentration is given, you need to calculate pOH, not pH. So directly don't find pH. First here OH minus is there now, so you can do like this, concentration of OH minus, because this is the easiest way. You can also directly calculate pH, but that is a multiple step. Yeah, I will tell that concept in the class, but now in this session you learn using pOH, I mean OH minus ion concentration. So pOH is equals to minus log of OH minus ion. How much it is? 10 power minus 2. Okay, so if it is 10 power minus 2, you write 10 power minus 2 here. So minus into minus, here it becomes plus 2. So this is the pOH of the solution. But the question is asking about pH. We have calculated pOH. So now what we need to do? Yes. So the pH plus pOH, the sum of pH plus pOH is 14 at 25 degrees Celsius. At what temperature it is 14? At 25 degrees Celsius it is 14. Okay, it means if I change this temperature value, the sum of the pH and pOH value also changes. Okay, now what I will say is, the main confusion or the main question is about this particular relation. So will all the time pH plus pOH will be equals to 14 or it will be different? Yes, I can say it as different. Why it is different? Because these values are temperature dependent. They depend on what? Temperature. So at 25 degrees Celsius only pH plus pOH equals to 14. If I change the temperature, this relation also changes. Okay, let us discuss. So if I take 90 degrees Celsius, the sum of pH plus pOH will be equals to 12. So on what basis I am saying this? Yeah, listen to me very carefully, you can understand them. See, when you take a water molecule, how it will dissociate? It gives you H plus as well as OH minus ion right now. So when one water molecule is getting dissociated as ions, you are getting equal number of OH minus and equal number of H plus ion, like both of them are 1 and 1. So you can say equal. So if H plus ion, OH minus ions are same, you can say solution is neutral. So water is a neutral substance, neutral compound. Okay, why? Because it gives you same number of H plus and OH minus ions. That's why you are saying it as neutral. Okay, so if you remember, when I started this discussion of equilibrium chapter, I told you about this symbol. This symbol indicates what? The reversible reaction. Okay, reaction taking forward, reaction taking backward. If this is involved, then you can say it's a reversible reaction. If the arrow mark is something like this, you can say the biggest arrow, which side, longest arrow, forward side, no? So reaction is moving forward. If this is small, means what? Backward reaction is less favored, reaction is more favored towards forward, like that. But if I mention it like this, equally forward, backward reactions are taking place. So you can say this as equilibrium state. So water at its equilibrium state, we can call its constant as equilibrium constant K. How can you write? The concentration of products, okay, H plus and OH minus divided by concentration of water. So that is written over here. I am directly writing this side. Okay, see, water concentration multiplied with K, na, it's a constant. You can write it as Kw. Okay, so this Kw will be equals to H plus ion concentration multiplied with OH minus ion concentration. Now this Kw is called ionic product of water. What you can say? Ionic product of water. Ionic product of water. Kw is what? Ionic product of water. So now the ionic product of water at 25 degrees experimentally determined value అంటే ఒక ఎక్స్పెరిమెంట్ చేస్తే ఆ ఎక్స్పెరిమెంట్లో వాళ్ళకి ఏం తెలిసిందట అంటే the ionic product of water, that is Kw value, is equals to 10 power minus 14. How much it is? Kw equals to 10 power minus 14. అంటే 10 power minus 14 ఎలా వచ్చింది? How we got this 10 power minus 4? This is a question, right? So you check here, equal number of H plus, equal number of OH minus ions are formed when one water molecule is dissociating. It means the concentration of H plus ion is found to be 10 power minus 7 as well as OH minus also 10 power minus 7. So the multiplication, the product of these two is 10 power minus 14. So that's why Kw value is 10 power minus 14. Okay. So this is the important relation in order to get our pH relation. Okay. So this is the story at 25 degrees Celsius. Okay. So now I am taking same water. ఇదే వాటర్ని నేను 25 degrees దగ్గర డిసోసియేషన్ కాకుండా నేను దీన్ని ఇప్పుడు 90 degrees Celsius దగ్గర డిసోసియేట్ చేసామనుకోండి, you will get same dissociation but the values are different. Same H plus ion, same H plus ion, same OH minus ion, but at what temperature? This is at 90 degrees Celsius. సో ఇక్కడ కూడా సేమ్ డిసోసియేషన్ జరుగుతుంది. ఇక్కడ కూడా కేడబ్ల్యూని అయానిక్ ప్రోడక్ట్ ఆఫ్ వాటర్ అని అనాలి, హెచ్ ప్లస్ అయాన్ ఓహెచ్ మైనస్ అయాన్ అని చెప్పాలి. బట్ ది కేడబ్ల్యూ వాల్యూ ఎట్ దిస్ 90 degrees ఈజ్ ఫౌండ్ టు బి 10 power minus 12. అంటే ఇక్కడనేమో 10 power minus 14 అన్నాం, ఇక్కడనేమో 10 power minus 12 అంటున్నాం. బట్ బికాస్ దిస్ ఈజ్ ఎట్ lower temperature 25 degrees, this is at higher temperature 90 degrees. Ante we can get a conclusion from this. As we increase the temperature, the dissociation of water is also increasing. It means dissociation of water is an endothermic process. Which process it is? Endothermic process. Ante enti sir? Ante aa dissociation anedi manam heat supply chestunna koddi ekku avutadi annattu. Okay, endothermic means that reaction is favored by absorption of heat. So here by absorption of heat the reaction moving forward, you can say it is an endothermic process. So that's why at higher temperature we have greater Kw value. Okay, 10 power minus 14, 10 power minus 12, which is greater? 10 power minus 12. Now in this case what is the concentration of each ion here? It will be 10 power minus 6 and this is also 10 power minus 6. If you multiply both of this number, it becomes 10 power minus 12. So this is Kw value. ఇలా మనం క్యాలిక్యులేట్ చేయాలి. ఓకే, ఇక్కడ కూడా అదే ఫాలో అవుతున్నాం. అప్ టు హియర్ ఇట్ ఈస్ క్లియర్ నా? యా, లెట్స్ మూవ్ little more deeper to get that pH relation. So to this formula I am applying log. Okay, log Kw it becomes, and this becomes log concentration of H plus ion and concentration of OH minus ion equals to 10 log of 10 power minus 14. ఇలా రాయొచ్చు కదా. ఈ ఈక్వేషన్కి అన్ని వైపులా లాగ్ని అప్లై చేసాం. ఓకే, సో దెన్ నెక్స్ట్ ఐఎమ్ ఇన్సర్టింగ్ ఎ మైనస్ సింబల్ ఇన్ ఫ్రంట్ ఆఫ్ దెమ్ లైక్ దిస్. వై ఐఎమ్ డూయింగ్ ఆల్ దీస్ థింగ్స్ ఐ విల్ టెల్ యూ. సో నౌ before inserting this minus here, yeah, you put that minus. Okay, log a into b, if we have, what you can write? I hope you have studied this logarithm tables and all in your class 10th. If not, you just follow me what I am saying. So log a into b we have, then you can write this as log a plus log b. You can write like this. So here also minus log is there now, so minus as it is log concentration of H plus I can write plus minus log concentration of OH minus I am writing. Why this minus symbol came here? Because this is the minus applicable for both of them. Okay, ila rastam ardhamaindi kada? Yes. So why I have written like this? Whenever you have pH, what is its formula? Minus log concentration of H plus. See here I have minus log concentration of H plus, so that is pH. So here it has given as minus log concentration of OH. You can write this as POH. Okay, and in between that addition symbol is there, so you can write pH plus POH is equals to, so this number you can write over here, it equals to 14. So now this is equals to minus log of Kw, so that is nothing but pKw. What is that? pKw. So this is your final relation. This is your final conclusion. Okay, so that's way at 25 degrees Celsius on pH scale. If we observe pH scale, I hope మీరు అందరూ కూడా pH స్కేల్ని చూసే ఉంటారు, అంటే టెక్స్ట్ బుక్లో అట్లీస్ట్. సో అందులో ఎలా డిసైడ్ అయితే ఎలా రిప్రజెంట్ చేస్తారు? సో ఇట్ విల్ బి జనరల్లీ గివెన్ యాజ్ 0 to 14 and in between here the middle number, that is 7. Okay, if it is below 7 you are saying acidic, above 7 you are saying basic. Okay, and now remember, if I say a substance is highly acidic or more acidic, that's its value will be more close towards 0, and weak acid means its pH value will be more close to 7, less than 7 but more close to 7. This is weak acid area, this is strong acid area. Okay, similarly when I say basic, if it has 14 or more close to the 14, it is stronger basic region, and it is more close to the 7 means greater than 7 but close to 7. This is weak basic region. Like this you can understand the pH scale. Okay, ardhamaindi kada? So how can we got a relation? So using ionic product of water, that is pH plus pOH equals to 14 at 25 degrees Celsius. So that's why our pH scale will be looking like this. Okay, in the same way, if I ask you to describe pH scale at 90 degrees Celsius, at 90 degrees Celsius you should describe this using this value, because we have Kw value as 10 power minus 12 right now. So now what happens here? At 90 degrees Celsius, what happens? The pH scale goes from 0 to 12. Why? Because there it is Kw value is 10 power minus 14, then we got it is 0 to 14. Here it is 10 power Kw value at 90 degrees 10 power minus 12. So values goes from 0 to 12. So between the middle point is 6. So below 6 acidic, above 6 basic. Okay, I hope up to here it is clear. Now there will be a question given on pH scale. 7 is always neutral. Will this statement is correct? Once again, the pH is equals to 7 represents neutral in all the cases. Will you agree with this statement? No, you should not agree with this. Why? Because pH scale is a temperature dependent. What I am saying? pH scale is a temperature dependent. If you change the temperature, that values representation also changes right now, because at higher temperature more dissociation. If it is more dissociation, then the pH scale varies takes place. Okay, so because if you see pH equals to 7 is neutral only at 25 degrees Celsius, but if I say the same 7 value at 90 degrees Celsius, you are going to get 6 as a neutral point. It means definitely 7 is greater than this neutral point, no? So 7 falls under basic region in case of 90 degrees Celsius. Ila manam pH scale ni ardham chesukovali. Okay, I hope the discussion is completely clear, right? So in the next video I will be explaining how to calculate pH and pOH of weak acids as well as weak bases. Okay, so ఇంతవరకు మనం ఏం డిస్కస్ చేసాం? How to calculate pH of strong acid, strong base. That's why I have taken only 2 examples of HCl and NaOH. So in the next session I will be taking acids which are weaker. Weak acids means like organic acids like acetic acid, okay, or benzoic acid, like that kind of things. Where it comes to weak bases means what? Ammonium hydroxide, these are weak bases. Okay, so for strong bases we discussed alkali bases are there now, like NaOH, CaOH twice, those are strong bases. Okay, so hope the discussion is clear. Now I will be giving you 2 questions. You must solve them and mention your answer in the comment box for this discussion. Okay, and stay connected with us for the next session on these acids bases, particularly about weak acids and weak bases. Okay, right. The question here I am mentioning about calculate pH of 2 into 10 power minus 4 molar HCl. Okay, how can you calculate this? Okay, do this and mention your answer in the comment box. Second question here, calculate pH of pH of 10 power minus 4 molar NaOH. Okay, so do these 2 questions and let me know your answer in the comment box. Okay, so thanks for watching. Stay connected with our NEET World YouTube channel. Thank you.